Lesson 12 focuses on solving equations, and we've been able to solve equations for a lot longer than we thought we have. For example, x minus 7 equals 3. You might hear someone in second grade teacher saying, what take away 7 is equal to 3? We've been solving these forever. And you might already know that 10 take away 7, 10 minus 7 is equal to 3. But we can actually use algebra and algebraic practices to solve equations by doing what we call the inverse operations. So the opposite, or the inverse of subtraction, is addition. Because if we take the number 3 and we subtract 1, we take the number 3 and we add 1, we're going to end up with 3. So if you do the inverse operation, it cancels out what you've done. It doesn't change the answer. And we can think of equations like a balance. If we do something to one side, we have to do it to the other side. Another inverse operation would be multiplication and division. And one we don't think about a lot is if you take a number and you square it, we can also, quote unquote, undo it by taking the square root. So squaring and square rooting are inverse operations. They undo what they did to the other side. So if we take the minus sign, the inverse operation of subtraction is addition. So if we add a 7, since the equal sign is like a balancing beam, we got to do the same thing to both sides. Negative 7 plus 7 is 0. And we'd say that's x plus 0 equals 10. And we don't have to write 0. We know that adding 0 doesn't change a number, so we're not even going to write that 0 in there. So we have x is equal to 10. And our goal when we solve problems is to get x all by itself. Now that's a fairly simple one, but let's look at another one we might see. Something like this. The first thing that I see is that the left side looks pretty simple. There's 2 terms, that's it. But the right side of the equation, I have a 2 on the outside of a parenthesis with a quantity in it. So that says to me that first I need to distribute. I need to get everything to look like a polynomial. Polynomial on one side, a polynomial on the other. Then I can start picking on things to take away and really solving the equation. So let's do some distributing. So I'm going to keep this side the same. And then negative 2 times 8v is negative 16v. And negative 2 times a negative 7 is a positive 14. So now I've got 2 polynomials on opposite sides of the equation, opposite sides of the equal sign. And then I'm going to start trying to get the v's on one side and the numbers on the other. So first thing I want to do is I always pick on the little guy. So the one that's the smallest. And in this case, 16v is the smallest. So I want to get the v's to one side, the numbers to the other. So let's add 16v. He's the littlest. And I'm going to end up with negative 16. Negative 6v plus 16v is 10v, and a positive 10v. And this becomes 0, so we're left with just positive 14. Now I want to get that v by himself, make him kind of lonely. So let's get rid of the 16 by doing the inverse operation, which is adding 16. This becomes 0, so I'm left with 10v equals 30. Now, since I have 10v equals 30, I'm going to rewrite this so that I have a little more room. We actually know that this is the same as saying 10 times v. However, we don't write that multiplication sign in there because it would get very tedious. So the inverse operation of multiplication is division. So this time we're going to divide both sides by 10 because we want to get that v all by himself. And 10 divided by 10 is 1. And when you multiply something times 1, it doesn't change its value. So we can get rid of that altogether. We get v equals 30 divided by 10, which is 3. So in this case, the solution set is 3. And no other values, just the 1. Now let's take a look at an example that has fractions. Whenever we had fractions, people tend to get a little scared. But the thing of it is that fractions just mean division. When you have a fraction, it means you're taking a number and you're dividing it by another number. So in this case, you're taking x and you're dividing it by the quantity x plus 2. So I would like to get rid of that nasty fraction. And the way I'm going to undo or do the inverse of division is by multiplication. So I'm actually going to multiply both sides by that whole quantity x plus 2. What ends up happening is you have x times x plus 2 over x plus 2. And x plus 2 over x plus 2, x plus 2 divided by x plus 2, is the same number. So we can cancel those out because they end up being just 1. So we'll get x equals 4 times the quantity x plus 2. Now we've got to do some distributive property. So we'll get x is equal to 4x plus 8. And we want to get all the x's on the one side. So what I'm going to do is I'm going to subtract x, 4x. And it's not very intuitive here why you subtract. What I want you to remember is that this is a positive. So it's being added. So we're going to do the inverse operation, which is subtraction. And this is a positive 1x. We're going to subtract 4x from it. So we'll end up with negative 3x equals 8. Here's the part that's tricky. Again, I have this multiplication there that we don't always write, but it's there. And I want to divide. And I'm going to get negative 3x divided by negative 3. Negative 3 divided by negative 3 is 1. So I'm left with x. And then we're left with this 8 divided by negative 3. So we know a positive divided by a negative is going to be a negative. And 3 goes into 8 twice. A 2 left over. And furthermore, that 2 left over is 2 out of 3, our divisor. So we're going to get negative 2 and 2 thirds. Or if you put it in your calculator, like a lot of you like to do, it will end up being negative 2.66666, repeating. Okay. All right, and my last little trick that I wanted to show you, we kind of went over this in class. When you have two fractions, you can undo the fraction by multiplying both sides by the denominator of 1. So we have x times x, which is equal to 5x over x and x squared over 5. And then we can multiply, get rid of that 5 or x, and we end up with 5. And then we want to get rid of this other fraction, so we multiply it by 5, multiply this side by 5, and then you're going to get 25 equals x squared. This is a lot of work to get to this point down here. So I'm going to show you a little shortcut we went over today. It's called cross multiplying. You can only use cross multiplying when you have two fractions set equal to each other. And what you do is you make a little bow tie. So I'll do it in red here. Okay. X times x and 5 times 5. So you end up with x times x is x squared, and 5 times 5 is 25. So you end up with 25 equals x squared. Now the inverse operation of squaring is square rooting. When I take the square root of x squared, the squaring and the square rooting do each other, so I'm just left with x. And the square root of 25 is 5. However, we do not want to forget that it's plus or minus 5, because negative 5 times negative 5 is equal to 25, just like 5 times 5 is equal to 25. So we write plus or minus. We can also write this in a solution set with negative 5 comma 5, because those are two solutions to that problem.